to our FTTN national media launch. Obviously it's a very proud day to be launching this great technology. As you'll see from the briefing sheets, we've got a two parts to the day really. The first part will be a presentation from our Chief Customer Officer John Simon, and then from our Chief Architect Tony Cross. John will be talking about the product side of the launch, and Tony Cross will be addressing the technical side of the launch. And then after that we'll open up the floor to a Q&A session for the final half an hour. So with no further ado, John Simon, our Chief Customer Officer. John.
Thanks, Tony. Good morning, everyone. Thanks for joining us here this morning. Obviously a very proud day for all of us here at NBN with both this announcement and the media launch today. Really this is announcing the next step on our MTM journey in bringing and delivering super fast broadband to all of Australians. This is the next leap forward for us, and you'll see through our announcement how we plan to deliver these services to the market, and it's a key day for us and a key day for all of Australia in us being able to announce this today. So what are we announcing? We are basically announcing that our fibre to the node service is now live and operational, and through RSPs are now placing orders for service, so end users where we've released the footprint for service can now commence ordering. This really will enable all of Australians, at least those on the FTTN footprint, to be able to get super fast broadband and be digitally enabled far faster than other alternatives that we have. How do we do that? Well, basically it's going to happen more quickly with less inconvenience for end users, and importantly at less cost to the taxpayer. Let me just explain why that is. You'll see that we'll be getting to some 3.7 million homes by mid-2018. Our total footprint for FTTN will be more like 38% of the entire footprint when the rollout closes. That's about 4.5 million homes. But from that you can clearly see that by mid-18 we quickly accelerate. And over the next 12 months, you'll see by this financial year we'll have at least 500,000 homes ready. So we do that more quickly for two reasons. One, we've already got some 220,000 homes that are ready for FTTN, and as we get more experience through the launch, we will commence to accelerate the release of those premises, and we are rapidly building more, and the build time is far quicker for FTTN than it is for FTTP. We will expect to have 1.7 million active end users by mid-2018. The nice thing about FTTN is that the standard business model is that we do not need to have an appointment with the end user in the home. These services are activated from the node or the pillar. All the end user has to do with the RSPs, swap out the modem. So a far simpler installation process, a far more convenient installation process, no appointment needed, and hence why we believe we'll be able to go faster with less inconvenience, and ultimately lowering the cost overall. As you know, through our corporate plan we've announced that the cost to connect a premise on fibre to the premise is around 4.4K, so $4,400, versus the FTTN cost will be around 2,300. So getting broadband out there faster, getting it out there more cost effectively for taxpayers, and also from an end user experience with less inconvenience and being able to order that service faster. In terms of what is the product, I just want to remind everyone that while it is an FTTN service, the product architecture and what we've released is consistent, and I'll show you in a few more slides, with what we're doing with FTTP and fixed wireless. In fact, of all of our products will follow a consistent product architecture. And that users will be able to order what we would refer to as the standard sort of asymmetric service that you would have with residential broadband, which is what we call peak information rate. So for example, 25 megabit down, 5 up, asymmetric. But also for business. So some 90% of Australian businesses use up to 10 megabit symmetrical service, where the information rate is committed. And so we'll also support our business services on this service as well. So it's not just for homes, for residential, but it is both a business and residential service, which is really important. And for businesses as well, we believe we'll be able to get faster connection. And if you think of businesses in retail shop fronts, for example, less inconvenience because we're basically using that short run of copper into the existing location rather than having to dig up and do civil works in places like retail malls and shop strips. So faster and I think with better customer experience. From all the indications and network designs, I've seen the trial at Belmont where many users will be able to access 100 megabits down, 40 megabits up. It looks at this early point that we're talking somewhere between 50 to 60% will be able to get that. But 90% of all of our end users on this footprint will be able to access speeds of a minimum of 50 megabits down and 20 up. Now this is a significant difference and a significant uplift on what the average DSL2 type service is today, which probably ranges in the range of about 8 to 10 megabits down and 2 up. So you can see quite a significant boost and will make a big difference for end users, and we're already seeing that from the trial accounts that we had in Belmont and already a couple of live services that have gone, the orders have been placed and activated. One live service has come through our RSP Exetel, through Optus Wholesalers aggregator, delivering to a small business is already placed and already active. One point I do want to clear up, there's been some conjecture that during the coexistence period, now this is the period from when we RFS an area, so when we go live in an area, 18 months later, the physical copper gets disconnected, the old PSTN. So there is an 18-month period where end users must migrate. There has been some rumour, quite incorrect I've got to point out, that this service will only deliver a speed of up to 12 megabits during the coexistence period. That is incorrect. Services will be delivered at a much higher rate. We do during this period employ what we call power back off. So that basically doesn't send as strong a signal as we can or need to. It basically allows for a coexistence of ADSL services with VDSL services. So during this period of 18 months, there will be both coexistence of traditional ADSL2 services and VDSL services, and we employ power back off. Now, that even with power back off employed, the speed you'll hear about today is what we're getting. So obviously when we turn the power fully on, those will actually be able to have deeper reach into the network as well. But what I'm talking about around the 90% of subs will be able to access speeds, the 50/20 will certainly be delivered on. So it's important to clarify that. So what will the average Australian be able to do with this service? Look, when you go down the list, you see here video streaming, multiple high-def streams, using cloud computing, video conferencing, online gaming. You probably say, well, you know what, I can do that today. Well, you probably can. Some of you can, some might not be able to, depending on your speed. The issue, though, is not about each one of these individually. It's the fact that more and more homes now in Australia have connected devices. So in the average Australian home, there's 8.2 connected devices to the internet. Normally 3 or 4 mobile phones, most likely one sort of desktop, probably at least one tablet, maybe more, and then of course at least one big screen, which is now IP streaming, if you like, some form of video content. That will only grow, and of course this concurrency is the issue that we're solving for. It's not solving for one connection for video conferencing or an improved user cloud performance. It's actually the concurrency in the home of all these multiple devices. And so therefore, when you look at what happens, what type of speed you need to be able to support them, this slide here gives you a feel for that. So, you know, if you've got a few people surfing the web and just doing some emails, each one probably only needs a megabit or 2, and you're okay there. You then add someone at the other end, high definition IP streaming, probably 5 megabits. If there's 2 large screens, you probably need to get to 10 megabits. So quickly you start to see a couple of people surfing the web, watching a few YouTube videos on a small screen, someone watching on a large screen or a movie, quickly they're at 12 and 14 megabits. And that's why today people are complaining, because the average ADSL speed of sort of 8 to 10 isn't allowing for that concurrency to occur. At 25.5, there is plenty of space. So when we talk about the speed that people need, we're all talking gigabits. That's nice, but the reality is 25.5 is going to cater for many, many homes, and we'll be delivering 50 megabits on this service. So this does give us plenty of room for future growth and expansion. Equally for business, you can see a business that has multiple voice lines, normally dimensioned at about 150 kilobit per line. If you had 10 parallel or simultaneous lines, you need between 1 and 2 megabits of concurrent service. Obviously, what's more important for them is both their up speed in being able to send large files, and hence that's why a service like a 5020 is good for business, 20 megabits up. And then if they're using business grade services as well for video conferencing, probably wanting a higher capability. But as I said, this is the type of speed they can support small and medium businesses, and that's what I'm referring to here. I'm not talking about large enterprises, I'm not talking about connecting their data centres, because most large data centres are well catered for. There are many fibre providers today, but there's large amounts of Australian businesses that aren't able to get that quality connection, and this service, both from a limited information rate and or a peak information rate service that I talked about, can deliver that concurrency and those multiple applications. So this is for many small and medium businesses and for branch offices of large organisations very much a big game changer. And if you imagine that you're in a regional area and you're a design company or providing more knowledge work information, having this type of capability is a real game changer for you, because now you can start to service your customers across Australia in a far more ready manner, in a far more reliable manner. This slide just talks about the product architecture that I mentioned about. So you can see here residential broadband, FTTP, these speeds you know about, from 12.1 to 140, fixed wireless. On the other side here has a 12.1, 25.5. We'll be launching a 50 type 20 speed also, up to 20 megabits coming through in December. You can see long-term satellite will also have 25.5. And you can see similar type of product construct around the speed tiers, minimum of 25.5, and then we'll do up to speed tiers. So what does that mean? And up to means when a service is ordered, the RSP will be able to have the line rated. If you think about it, FTTN, that last bit of copper is your link, it's not shared by anyone. We can rate that line and provide an indication and kind of performance as to what speed tier it falls into. And if the end user wants, they can order a higher speed tier. As I mentioned before, most voice these days is now provided over VoIP. And in terms of business services, these are these symmetrical services I talked about. We can deliver up to 40 megabits, also with enhanced SLAs to provide faster turnaround. So from a service perspective, while we're using multiple technologies, that becomes quite irrelevant for the end user. It's the service that's being delivered to them in a consistent manner, irrespective of the technology choice that's being used by us. Why is it easier to connect? Quite simple. We know that in FTTP, one of the biggest problems we have is getting that last part, the leading conduit, all working through to the home. And in this environment, we avoid that because we're using that short piece of copper that's in the leading, that's already there, and therefore only having to activate back at the pillar. This is an important part. We know through our end user surveys that we do, NBN related services have a pretty high net promoter score. They're just around the 8, just under 8 in most cases, which is good, high strong recommendation. But the one area that we constantly get feedback on is the time to install and the problems with installing. So we do believe that this is going to go a long way for many of these users where we won't have to perform any civil works in the front yards of these places or on the sides of the houses, because effectively all they need to do is swap out their modem, which the RSP will supply. They'll connect where their old ADSL modem was, they'll put their new VDSL in modem. ADSL, the modem will be backwards compatible, so it will support ADSL2, and then we'll convert it to pillar. But if required, RSPs will provide a professional install if that option is needed. But at this point, we think that the far greater majority will run with the self-install approach. Of course, Tony's going to speak to you a bit more about what happens, what are the next stages of FTTN. We are constantly amazed at the rate at which this technology is evolving, and the speeds that we're getting are fantastic speeds and will make a big difference. But we actually see ongoing developments around GFast, which we'll know will take this technology into another level of speed again. And also with FTTDP, this is effectively micronodes where we can take the fibre further into the network. I guess my important point I want to make here is that some people think when we talk about FTTN that we're still using all of the old copper network. We are not. Most of the copper network has been removed. We are deploying fibre deep into the network to a node that's closely located to most premises, and we're reducing the amount of that copper. So therefore, when we talk of FTTN, it is still fibre, you've got to remember the F, to the node, and we're just using that last part of the copper to basically transmit the remaining signal. And that has made a huge difference from the experience that we're seeing at Belmont 9. And we expect that we'll continue to develop further with things like GFast and FTTDP, but I'll let Tony speak to you more about that going forward. So this is great news, we believe, for not just for us, but for all Australians and business, because 4.5 million premises will be covered by this technology, and the results, and we're up to, is very encouraging. We are starting to see some orders flow. We will take it slowly to start off with. We will be releasing the first node in Belmont. That's about 2,000, just under 2,500 premises. As we get more orders through that and work the end-to-end process, we'll then up the release to probably 3 to 4 SAMs, or serving areas per month, and that will take another 10,000 premises. We expect around January to be releasing some 60,000 premises a month, and that's how we accelerate the activation rate. Remembering that we already have built 220,000 of these ready to go. So we really have a stability period, just making sure that we've got the right end user and customer experience to go through. So I'll hand over to Tony, who'll tell you a bit more about where this technology is evolving.
Thank you, John. Good morning. My name is Tony Cross. I'm the Chief Architect at NBN. Today I'll just run through probably 4 things. One, a little bit about what FTTN means to NBN, why we're doing it, a little bit about the technology itself, a bit of an insight into how the Belmont trial's going, and really what FTTN sets us up for in terms of future technology. So first of all, why are we doing FTTN? Really, we did have a number of issues in trying to deploy fibre all the way to the home. Certainly as you get closer to the home, the challenges get a little bit tougher and tougher each meter you go closer. And the leading conduit itself was a big challenge for us. We find in instances it was blocked or damaged in some way, or even it wasn't in existence. The original copper network was directly buried in that last bit from the pit to the home. So that was one set of challenges. And MDUs as well, trying to go back into an MDU and find a fibre pathway through that building to get fibre all the way to those residential apartments was a very, very big challenge for us. And it's a challenge for everybody around the world, you know, trying to go back into brownfield areas and put fibre all the way to each of the buildings. And of course, FTTN steps over all of those challenges by reusing that last bit of copper. It's already laid, it's available for us to use, and we'll go through some of the trial results and show you what the service speeds are like then. So really as a technology, I'll re-emphasise the point John made. We are taking the fibre a big step closer to every end user through this deployment of FTTN. It is the same fibre architecture back to the exchange that we would use if it was an FTTP rollout. So that sets us up well for any further extension of fibre beyond that node location. So it really is common infrastructure all the way back to the central office, to the exchange from the nodes. So all of that is an investment not only for now, but sets us up well for the future. The copper line from that pillar to the home is a dedicated pair. So what that means is the end user gets the full capacity of what that pair can deliver as part of the experience with FTTN. And the really, really, really magic thing about FTTN is the vectoring. So VDSL alone would tend to interfere with itself and bring down the service speed, but once you put vectoring on there, what it does is it brings the service that copper line can support very close to what you'd be able to get within the laboratory for that same piece of cable. And the best analogy I can give you for this, it's not exactly right, but if anybody's experienced noise cancelling headphones, that experience you get when you flick the switch and you suddenly get all that background noise disappear, that's kind of what vectoring does for a digital VDSL service. It just gets rid of all that background noise, all that interference, and you get a really clean VDSL signal down on top of that. The cabinets themselves come in a variety of sizes, so we can go all the way up to 384 services off the one cabinet. And obviously we put the right size cabinet in for the size of that node, so we've got a range of options there that we can choose. So a bit now about our early experience with this in real world scenario. So this is a set of results that we've got up at Belmont, New South Wales. What we found is that for users who are within 400 metres of that pillar location, their speeds are stable at 140, so you can argue fibre-like speeds within a 400 metre radius of the cabinet. Going a little bit further out to 700 metres, still getting 60-20 at 700 metres. Now our data tells us that about 90% of the Australian population lives within 700 metres of their pillar. So it really shows you that we'll be able to get this 50-20, pretty much to 90% of the population. And again, I'll re-emphasise, this is why we've still got the power backed off in the ADSL spectrum from that node. We do that because there are still working services coming from the exchange, and if we went full power today, they kind of overpower the ADSL that's still coming from the exchange. We don't want to interfere with those existing ADSL services, so we wind the power down at VDSL in that ADSL spectrum so that we don't overpower those ADSL services. Once the migration period's over and all those ADSL services are turned up in the exchange, we'll be able to bring the power in that band up on the node, and we should see with that improvements in data speed. I think the really important lesson that we've learned from this is serving MDUs from outside the MDU, from a node outside the building, is very, very doable. So being able to then just run the service over that last bit of copper through the MDU internal wiring into the end homes allows us to move much more quickly in delivering service into the MDU footprint as part of the Australian Union. And that's a huge win for everybody because it means we can go faster and users can get a really good service experience much sooner. We get the revenue in the door, keep our big funding demands down. And just to re-emphasise, these are just on the existing primary pairs that those end users have been getting that POTS telephone service over for decades, getting their ADSL service if they have that service today. So there's it's just running over that existing copper. So lastly, moving on to the road ahead, as I said, this is an investment that sets us up well for anything further we want to do in this node footprint. That backhaul fibre has got capacity in there to do other things, take fibre deeper if we need to do that. It allows us to go a lot quicker because we step over a lot of those issues that trying to get fibre all the way down that last bit of the street infrastructure and through the leading conduits into the homes generates for us. It steps over that. The results in Belmont are fantastic. We're really pleased with what they're indicating about the capability of FTTN, vector FTTN. And also that idea that the services will get even better when we're able to use that ADSL spectrum after migration is over. And also we've seen first commercial launch of G.Fast mentioned, where that's open to us as a future option as well. Nothing we're doing today prevents us from doing that. In fact, quite the opposite, enables us to take G.Fast at the right time within the NBN use of technologies. Thanks very much.
Okay, thank you, Tony. Just clarification. So as John said, Exetel has signed the first NBN FTTN active subscriber. It's a small business in Belmont, and they're getting 100 meg down, 40 up on their FTTN service. So we can move to the Q&A now. So I'd like to welcome John Simon, Tony Cross, and also Peter Ryan. Peter is the EGM group for regional deployment. So Peter's been working on the JDWC trial, basically rolling out the FTTN network, getting the cabinets in place and getting them activated. So any questions about the construction side of the operation, direct them to Peter, and the other chaps will answer from product and from technical. Okay.
Hi, Alex Huttervoort from iTWire. When you read the whirlpools of the world, they talk about only a certain amount of bandwidth going to each node, and then they divide that by the number of users, and they cry that there's not enough. How much bandwidth is going to each node, and does it depend on how many end users are on that node, so that you can deliver these speeds?
Yeah, so the nodes themselves can take multiple gigabits back from the node, and what we do is we track the usage on each node, and when we see the need to upgrade it, we can upgrade it. We just add more SFPs into the node. We've got plenty of fibre there back to the exchange, so we just upgrade the node as we need to.
And sorry, what's an SFP again for those?
Small form pluggable. It's basically an optical line driver, if you like, that allows you to light up the extra capacity back from the node to the central office.
So that's something that's easy to do. You can upgrade very quickly.
Very easy to do.
Stuart?
Yeah, that committed rate we have for the business service, wouldn't that depend to some extent on how much capacity the retail service provider had commissioned in the back end of the network, the connecting vertical circuit or something? So to ensure that the end users get that rate, are you going to require retail providers to provision their end-to-end capacity to a certain level to guarantee that rate?
Sure, so let's be clear. We only provide one part of the end-to-end service. The RSP plays a critical role. So in all the speeds I've talked about here, it's what we deliver back to our port interface. The RSP then connects their backhaul and their CPC, so they've got a dimension there. But RSPs do this today. They provide business services and provide community information rates.
So what you're saying there is not a product that might be advertised to the end user unless the RSP.
Our customer is the RSP. Our customer is the RSP.
Right, okay.
The RSP takes our traffic class 2, so that committed information rate is what we call traffic class 2. They would sell that at a very different price.
Oh yeah,
I'm
I'm aware of that. I
Yeah.
thought it was really clear from what you were saying. That wasn't
Correct.
a provision to the end user.
Yeah, no. So none of these services are to the end user. All these services are our offer to our customers who are the RSP. They then take those offers and bundle around their CPE solution. Particularly in business, as you know, there's often quite a layer of CP, layer 3 services that gets delivered over the top. Yeah.
The speeds in the development trial, they're averages or bit rates, or one that's on the table? Those are the average speeds?
So what we do is we measure those speeds, count divides, divide by the period of time that we've been looking at, and those are the results.
We're talking about any testing for the committed, committed 40-40 offshore, because obviously that's a pretty big pool to get guaranteed bandwidth to 40 megabits.
Well, that's going to depend on distance in terms of being able to get those speeds. But the same would apply. It's a matter of counting the bytes over the period of time you've been running the service. So, but it would be over from a certain distance from the node to be able to do that.
And you've done separate tests for the business service as well?
I don't know what testing you've done on business service.
The test that we have to do, so we're not going to go and test to see what they get. If it's committed, it's committed. We have to deliver that capability. So it'll probably be more associated with MDUs, FTTB type services, like short haul combo.
Why is there a major discrepancy between the figures NBN Co is reporting and figures reported by Chorus? And why aren't alternate construction techniques not being adopted to further reduce FTTP rollout costs as is happening in New Zealand?
I don't know what figures you're referring to.
Well, there's been some concern that FTTP rollout costs is fundamentally expensive, which is why we've gone with a multi-technology mix. We've seen in the last year FTTP costs drop by more than $1,500, and it's expected to drop even further by next year.
Sorry.
A couple of days
Who's
ago,
saying that?
Bill Morrow said that we were adopting a multi-technology mix, similar to one adopted in the US, as if that was something that was agreeable. When we're seeing Chorus's success in New Zealand with FTTP as a result of dropping costs, why are we not considering a similar model?
So we can't compare our geography and our topologies to New Zealand. The very different landscape to New Zealand, and the costs are the costs as well. So we know for now, because we've rolled out to more than 1.2 million premises an FTTP network. We know the costs of that, and so we've got a real base. So there's no point comparing it to another country when we've got 1.2 million premises. We can say this is what it costs today. Even allowing for future decreases in costs, you still have a 2.3K versus 4.4K. So this is like all things, everyone would agree in the long term, is fibre, would that be the utopian solution? Yes, it would be. But we have a budget to run to, like everywhere, and we have time. So I think what we're trying to clearly do here is deliver broadband faster, which all Australians are crying out for. They want these services at high speed, and we've got to do it within a reasonable envelope. And when you take those three parameters, functionality, time, and cost, the MTN solution, and then we'll come up with delivers that in a multiple manner. And the nice thing about it is if things do change, and if the technology is advanced further and costs can decrease, we've got the ability of change to do that.
Sorry if I'm running small ground, but in terms of the speed that a person gets, we saw at Belmont that often the wiring to the actual premise was fine, but the in-home wiring wasn't sufficient to get the optimal speed. Who's responsible for making sure that speed is
So if there's a problem with a service, obviously the RSP will call us. We've got diagnostic tools to look at that. We'll determine where that problem is. If the problem lays in the copper between the node and the home, we'll fix that. If it's an issue with in-home wiring and a splitter needs to be installed, the RSP will take that responsibility for that.
Is that something they'll pass on or be able to pass on to the customer, or will that have to be?
That's up to the RSP to decide what services they want to charge for, what they want to bundle into their products. So our service is to the wall plate, first wall plate of the house, and that's where we deliver the speed. If there needs to be additional service, and there's no different to FTTP. When we install AMTD in FTTP, sometimes there is interference, it's calls, and all the connections of all the multiple handsets has taken place, and they either have to rewire or move to some form of cordless phone, which most end users are doing today.
And that's at the end user's cost though, normally.
Can be. It's up to the RSP. Some RSPs will bundle it in some kind of payment plan or services. Yeah.
Your trial, Belmont, was that just done by NBN Co? Was that done in conjunction with an RSP and retail service provider, and were the end users existing customers of the provider? Or
So done in conjunction with RSPs. Yeah.
so with multiple RSPs?
There were a number of RSPs that those end users were connected. Yes.
So those customers now remain customers of those RSPs with an NBN service?
Correct. They'll start there. They'll obviously place a proper commercial order to get a commercial service. They're up until now with the trials.
But in the meantime, they get the trial service, they will be disconnected.
I'm sorry to harp on this, but can I please get a response to Business Spectator's claims that NBN Co could save $3 billion by adopting an FTTP model similar to the one in New Zealand?
Sorry, I think we'll take your question offline. We'll get you some responses in terms of the corporate plan. I think it's specifically around the FTTN.
Sorry.
Just wondering, how does fibre to the building fit into the FTTN construct? It's going to be a large proportion of FTTN design, or it's going to be a
Fibre building is effectively an FTTN construct. It's just that the nodes, rather than being in the street, are in, I won't say the basement because a lot of buildings don't have basements, but they're attached or in a location, which is located in the building. But effectively, the technology is the same. But the nice thing about it is we have the choice now. Where, as Tony said, we can serve some of the smaller MDUs, for example, with a node out in the street. But a larger one that has the right facilities, you might decide to bring that node into the physical building or attached to the physical building.
Sorry, just in terms of that actually, have we determined what size, the number of MDUs that can exist to be served over a node rather than a fibre-to-basement solution? In terms of the, as a percentage of the Australian total?
Sure, your question is.
I mean, if you look at the number of apartment buildings in Australia,
Yeah.
have we figured out roughly how many can just be served using the FTTN solution sort of normal, rather than going into the actual communications with
Any building can be served from a node, any kind of building. The kind of choices that you make though is by adding that MDU, if it's a particularly large one, by adding that to the node itself, does it go beyond 384? That might be a trigger point where you say, well, we won't put that building on that node, we'll leave that node for all the other properties, and we'll take fibre to that building and put a node in that building to serve the residents there. In the majority of cases, the node will be able to serve that building. Majority of cases, it'll just be about those line counts and whether it pushes it beyond what's R384 can do.
I guess what I'm asking is, whether or not a rule has been determined to decide when that takes place.
The rule will be, does it fit in the 384 and have we got the reach? That'll be the rule. And then if we break the rule for any reason, we say, well, what's the right technology choice for this particular piece of geography? And it'll be on a case-by-case basis as to what we do.
How many copper wires needed to be replaced in Belmont because of the supposed degradation of copper and the plastic bags needed on copper? You see pictures of copper with plastic bags. Did any of the copper need replacing in Belmont? And if the copper in a particular area is that degraded, will there be new copper put in to houses, as you would have to do if it's degraded, or will you just be putting fibre in?
I think the beauty of the multi-technology mix is we've got now a range of options available to us to what we do, depending on what the circumstance is.
But if you had to redo a piece of copper, would you put copper in, or would you just say, right, we've got to dig a hole, let's put fibre?
Well, let me say, if the piece of copper you've got to replace is the lead in, that wouldn't trigger an FTT anything else bill, you'd replace that piece of copper. So it depends on where it is, how much of it is, what the cost of that is.
Sure, but I mean, if the copper has to go from the node to the house, I mean, you can put a piece of fibre from the node to the house, as far as I'm aware. So would you replace that piece of copper? You know, let's say every other house is perfect, but there's this one house, or there's a few houses, you would put copper in rather than fibre.
If it was one house, you'd find a way to get the copper to work. Just economics say that. Yeah.
Now, I know you've given percentage figures for FTTN and HFC, but given that the HFC is very widespread in the major capital cities, does this mean that most of the major capitals are going to be on HFC rather than FTTN? How do you make the decision, roughly?
So the guideline approach we take at the moment is where there is a HFC network, where premises are currently served by HFC, we will use HFC as the primary mechanism to deliver that service.
So HFC will be pretty widespread then in the major cities where there's two HFC networks.
Yeah, part of this whole program is to accelerate the build. You've got lead-ins, you've got a network there, the cable plant is in good state. We have to upgrade obviously the electronics and move to a new state-of-the-art software, but the physical plant work that needs to be done on the outside is far less than any other network. So that gives us the speed, it also gives us a much lower cost to connect.
Yeah.
And we've seen the speeds that we're getting now around the world where this has had substantial investments, a lot of R&D has been put into this technology. But in effect, yeah, you can interpret that where there is a HFC network there at the moment, the premises being served, that will be delivered through NBN HFC.
You go.
Okay. Andrew South, SIT News. Sorry, just to clarify, so there were 43 homes in the Belmont trial and 2,500 will initially be able to now hook up to fibre to the premises.
Order of service, yes.
Okay. The other thing is that I was wondering, you ran trials in a number of other places as well. I understand, for example, it being in the outer northern suburbs of Melbourne, some on the Central Coast. First off, what happened with those areas? And secondly, when can those other trial areas expect to receive FTTP?
Yes, those early trials were exactly that, or technical trials to better understand the technology. So now, as I said, we have 220,000 premises that are being constructed, and we've released the first set in Belmont, and you'll see over the next month further release in Belmont and Gorican, and then that'll expand into that, what we refer to as a JDWC. There was a construction trial that took place for that. That footprint will be the primary thing that we start to release commercially. But we just want to go through the next month as we start to release and get up to 10,000, 15,000 premises, get the orders flowing through the system, make sure the experience is right, and then we'll open the gates.
Two questions. First of all, we started in Australia, before we moved to the MTN, we started with what was predominantly an FTTP solution. You're obviously bringing out some impressive numbers today and talking about the ways you can deliver to Australians, but following on from that, is there a concern, firstly, that you can only do so much to win those people over and there will be some people that are just permanently disgruntled about the MTN? And how much do you have to do before you think you can convince everyone that this is an adequate solution or that it's going to serve people? Because as we say, you know, the whirlpoolers and the truthers are constantly talking about that it's not good enough. There's that sort of public relations battle and convincing consumers.
Yeah. Look, I think trying to have the noble goal to convince everyone is probably a bit too altruistic. I think I know what we're trying to do, which is to make available super fast broadband to 12 million homes here in Australia, so that they can all get at least a minimum speed of 25.5, and in many cases there are homes that don't even have speeds, you know, at over 5 megabits, and to the majority of the footprint, 90% at 50 megabit service. That's our goal, and to ensure that the network we build is upgradable and future-proof, and that's what we're doing. Whether that's going to make everyone happy, absolutely not, because there's always people that will always want more, and look, we understand that. But at the end of the day, we've got to be able to manage a budget, a time frame as well as the functionality, and that's just life. We're all dealing with that.
Do you think that there's people that see FTP as this marvelous solution, but potentially that the average home? I mean, what kind of users do you see?
Just look at our FTT footprint today. We've got 500,000, you're getting up to 500,000 users connected. Something like 18% order 100 megabit service. The greater majority of people ordering the service are at 25 megabits and below.
Okay.
Which proves the point.
Second question, you spoke about convergency and getting multiple services when we have 8.2 connected devices. We saw Telstra release their Cat 11 device last week. Do you think this is the future, that it's not so much about the peaking out at top speeds, but that we need to create networks? Just kind of speak to that point of multiple devices and how the FTTN solution is adequately going to serve that kind of convergency.
Tony can talk about it, but my thinking about this is you sort of see two types of users emerging. Those that want higher speeds who download a lot, so they're the fastest download, and then they choose when they watch or play, while others want sort of what I refer to as concurrent streaming. They're pulling a stream down. Those streaming services don't need super high speeds, they just need a quality bandwidth that's there and performs, particularly at busy hours. So if you think everyone comes home at, starting from 4 o'clock or 10 o'clock, that there just requires quality, consistent bandwidth. And hence what I was saying, 25.5 and 50 megabits is more than even in a 4K world, and we're not at 4K, think about where the content's at. We've got plenty of people to cater for that.
I was going to say to your point that the multiple devices simultaneously trying to do things with whatever network they're connected to, I think it's a good point. The idea that there is a single app that drives the demand for capacity, I think, is a small part of the equation. I think it's much more about that multiple users simultaneously, each taking modest amounts of data, but wanting a good experience, in doing that, and it goes to the concurrency ability of the network.
Just a couple of really boring questions. On electricity usage, my understanding is that you consume fictions no chemical, which is maybe 100 kilowatts kilowatt per hour. Is that about right? If not, what is the correct amount?
It's a lot less than that. It's a lot less than that. Typically, no, and it depends. Hot day, air conditioners running, the things that manage the environment will be factors. But they're about a kilowatt, 1 kilowatt, not 100 kilowatts.
So that's 1 kilowatt per hour. So
yeah, 1 kilowatt per node.
Okay, gotcha. And just the only other thing was the case study that you guys told in Newcastle Herald that Telstra said it would have cost him $10,000 to do the work that ended up being done on his property. Is that accurate, and is that going to be replicated in other places across Australia as FTTN rolls out?
Yeah, that was an estimate from the guys who did the installation. So there was no actual professional quote performed for it. But if you remember the layout, the premise, there was about a 15-metre driveway going up, concrete driveway going up, which then banked sharply down, get an underground connection, so to get the copper from the street to the house, then the driveway comes up completely. So that's sort of job you are talking in the, if I'm correct here, in the $1,000 per month. Peter, can you speak to that point about the expense of some of the existing leadings?
Well, as Tony said earlier, one of the great joys of FTTN now removes the requirement to go from the street to the premise, which is not only the most disruptive from the customer, but it's often very variable in cost and time because of the fact that we have everything from longer distances in certain circumstances, difficult terrain in terms of concrete, etc. As we seek to minimise disruption to customers, we try and do this in a way that, as I said, cost-effective disruptions, eliminating them.
I should know who's supplying your FTTN. I should know this, but who's supplying your FTTN technology?
FTTN is Alcatel-Lucent.
Obviously, the trial speeds have been working to make sense. Have you done some sort of testing to see how fast you can push it on short lengths? And linked to that, do you see future upgrade paths as being more about changing the software on the line cards with better DSL, or is it more a question of pushing further around? Maybe if you need not fast.
So the way DSL works, it's pretty similar getting are pretty much the top end of the range of what the VDSL can do. And that's about how many tones have you got, how many bits per tone can you insert, add them all up, and on a good copper line, you're not much more than 140 in terms of what VDSL can do. The steps beyond that though will be not so much software tweaks. There's a V plus kicking around within the industry, and that's basically adding some more tones and changing the spacing of how those tones sit within the spectrum on coax. They will give us a possible uplift. And the G.fast, of course, is more spectrum again, going all the way up to 106 megahertz in the first blush of G.fast.
So that would also be pushing fibre further in, like the G.fast is a short range technology.
It's and exactly to your point, those higher frequencies go less distance, so that increase in speed will be experienced over 200 metre loops, that sort of order.
Would you push the fibre out further, or would you just do G.fast in the existing cabinets, and then would you within 200 metres you're not
Why not a bit of both? So, the node is in a good spot for all of those homes that are centred around that node. So you get quite a lot of users there within a couple hundred metres. Not everybody lives far away, but obviously some do. And then you just put then tentacles of fibre out from that nodal position and put electronics closer to the home to get those other homes within the reach of the G.fast. But that's future. There's nothing that we're doing today that stops us from doing that. There's nothing today that's compelling us to do it. The speeds we can get out of this VDSL spectrum are really, as you can see, pretty impressive.
On the marketing front, is the idea that consumers will be aware they're getting an FTTN service, they're getting an HFC service, they're getting FTTP, or is the idea basically that ultimately RSP will just say, you've got 140, and that's all the end users will need to know, that you'll kind of abstract that access level?
Well, I mean, at the end of the day, they want the broadband experience, I would argue. We do talk a lot about the specific technology and the way that we discuss broadband in Australia, but at the end of the day, the service is what really matters.
So will there be any homes that will have both cable from pay TV cable as well as FTTN, or it's just the one or the other?
I think, as John said, wherever HFC exists, that's our go-to technology for that area. For all the reasons John said, it's a largely built network, lead-ins exist in many locations. We just need to upgrade the electronics, use some spectrum available to us on that infrastructure, and we've got services running.
And I mean, there are people complaining that one side of the street has cable and the other side doesn't. I mean, will you be rolling out more HFC cable in areas where it never got finished in particular suburbs?
Again,
because in those suburbs,
we've got that technology choice.
Yeah, so what you're talking about there are infills, so absolutely there are pockets in areas where you can see HFC and then HFC here, and there might be a street or two that's got nothing, or also I should say nothing, it's probably got an ADSL type service. That'll go into our design consideration, and Peter's team and that will look at that and determine whether we infill it. You would suspect that if there's HFC all around it, we will infill it with HFC. It wouldn't make sense to go and deploy another technology for one or two streets in amongst a whole lot.
Sure.
Okay, likewise, just following on from the last question, in suburbs which are HFC predominantly, but there are, for whatever reason, individual properties that can't access that network, so for example, the dual occupancy they're too far away from the HFC network to connect to it, what will you do in those situations?
Yeah. But when we announce HFC, I'll answer your question.
If Peter can just speak to one fact that we didn't quite, I know John mentioned it briefly, one of the big problems we've had with FTTP in connecting commercial users is that commercial areas are normally very high traffic areas. And so, for example, in Toowoomba, we had quite a few problems connecting commercial premises there. In Belmont, which is a really quite a visible high street there, running FTTP there would be quite difficult. So can you just speak to some of the issues we had in the past, the FTTP in commercial areas, against what we can do with FTTN?
I suppose with FTTP commercial areas, our biggest barriers have been where we have what we call multi-dwelling units, where we have multiple premises within a single block of land, and that can either be horizontal or vertical, and the reticulation paths for pulling cable through those is often not fit for purpose, it's very difficult. So, and also we're dealing both with the body corporate, and therefore needing to identify and liaise with that group. So it's greater complexity in terms of the construction that we do, and leading to increased cost and time. The FTTN solution means that we can, where the corporate is suitable, where the design allows us to bypass that and connect straight in. So we get both the cost and time advantage.
Another thing to remember on the commercial premises is that most commercial premises are leased rather than owned. So often it's the problem with the leaseholder and the landlord getting permission to install the necessary hardware. So it can be a real issue. Any more? No? Okay, Mr. President, I'd like to thank very much John, Peter and Tony for their time. Thank you all for coming along. If you've got any questions afterwards, come and see myself or Francis Curie, my colleague. We can help you out. Thanks guys, thank you.
Thank you.